Most people think OAuth already handles login, but OAuth was never designed to tell you who the user is. And that misunderstanding has led to broken authentication flow, leaked identity, and production incident at massive scale. In this video, we are going to perform a tech autopsy and dissect OpenID Connect, how it sits on top of OAuth, and how login actually works on the modern internet. So you never confuse OAuth, OpenID Connect, or JWT ever again. Welcome to Tech Autopsy. Let's start with the real problem. Whenever you log into an application, Gmail, a food delivery app, or a company dashboard, the application needs to answer one basic question. Who is this user? Everything else, permission, data access, personalization, depend on answering this question correctly. There are two main terms people often mix up: authentication and authorization. Authentication answers who are you. Authorization answers what are you allowed to do. For example, you may be logged in successfully, that means you are authenticated, but you still may not be allowed to delete data, that's authorization. These are related concepts, but they are not same. Now let's talk about OAuth. OAuth was never designed for login. OAuth was designed for delegated access, like allowing an app to access your Google Drive files without sharing your password. OAuth answers this question: can this application access some data? But OAuth doesn't answer the question, who is the user? Earlier, many developers started misusing OAuth for login. They treated access token as proof of identity. This is dangerous because access tokens are meant for APIs, not for identifying user. This confusion led to security issues, impersonation risk, and inconsistent logic implementation. We needed a proper identity standard, and that's where OIDC comes in. OpenID Connect is an authentication layer built on top of OAuth 2.0. Think of it like OAuth handles permission, OIDC handles identity. OIDC introduces a new token called ID token, which is specifically designed to prove who the user is. Let's use a real world example. When a user clicks login with Google, Google authenticates the user using password, OTP, or biometric. Once the Google is confident about user's identity, it sends verified identity information to the application. The app trusts Google as an identity provider, and this trust is formalized using OpenID Connect. Let's identify the main component involved in OIDC. First, we have the user, usually through a browser or mobile app. Then we have the client application. Next is the identity provider like Google, Okta, or Auth0. And finally, we have tokens which securely carry information. Each component has a clearly defined role. At a high level, the flow looks simple. The user interacts with the application redirects the user to the identity provider. After successful login, the identity provider sends back the token, including an ID token which contains identity information. Now, let's slow down and walk through the exact step. First, the user clicks login. The application redirects the browser to the identity provider. The user authenticates there. The identity provider then returns an authorization code. Finally, the application exchanges that code for tokens securely. You might wonder, why not return tokens directly? The authorization code is short-lived and useless on its own. This prevents attackers from stealing tokens via browser redirects. Tokens are exchanged securely from backend to backend, making this flow one of the safest login mechanisms. OpenID has multiple types of tokens, and each token has one clear purpose. The ID token proves who the user is. The access token is used to call APIs. The refresh token is used to obtain new access tokens. Missing these rows is a common and dangerous mistake. This slide is extremely important. An access token is not proof of identity. You should never use access token for login decision. Only ID token should be used to authenticate user. Remember this rule. It prevents many real-world security bugs. An ID token is a JWT, which stands for JSON Web Token. It is digitally signed, tamper-proof, and time-limited. Because it is signed by the identity provider, the application can trust its content after verification. To get an idea of how JWT token looks like, you can watch my previous video on JWT tokens. JWT has three parts. Header describes how the token is signed. Payload contains the claim like user data. The signature ensures that token hasn't been modified. If even one character changes, the signature breaks. On the backend, the application follows a simple process. It verifies the token signature, it checks expiration time, it then checks whether the token has issued for this application. Only after all checks pass, then only the app creates a user session. Let's clearly separate these concepts one last time. OAuth controls what an app can access. OpenID Connect proves who the user is. Together, they form a complete and secure login system. OpenID Connect is everywhere today. Social login, enterprise SSO, banking application, and internal company tools all rely on OIDC. If you have logged in using Google or Microsoft, you have already used it. Most authentication issues happen due to small mistakes, skipping token validation, not checking issuer or audience. These mistakes can turn secure systems into vulnerable ones. If OpenID Connect ever felt complicated, that's not your fault. Most explanation jump straight to token and flow without explaining the identity problem it actually solves. On TechAutopsy, we don't memorize protocol. We dissect system until the designs make sense. If this video helped you understand how login really works on top of OAuth, consider subscribing. In the next video, we will break down JWT from inside out, how it's structured, signed, verified, and why just using HTTPS is not enough. This is TechAutopsy, where we perform deep technical breakdowns.